Hello, everyone. We are the Arduino-based Mechatronics group. My name is Javier Jimenez.
My name is Nathaniel Morgan.
My name is Nathan Petrie.
My name is Henry Salinas.
And I am Tefil Tomiwa.
Okay, so a little bit about the project background. So our sponsors are the Mechanical Engineering Department and Professor Shayesta. And the goal of this project was to create a set of mechatronics and measurement systems labs that will build upon each other each week. And the target users are sophomore and junior level mechanical engineers. And it'll introduce an array of different topics such as mechatronics, obviously, the Arduino microcontroller, how to integrate the software with those components, and then different types of coding like C coding.
To begin the design of the labs, we created a list of all the Arduino connectable components we could think of. So different sensors, outputs, etc. And we knew we wanted to group them by those categories. So the inputs, and different types of inputs, outputs, different types of outputs, and then arrange them by progressing difficulty so that the student could use what they learned in the earlier labs on the later ones. So after narrowing down the list to something that could be fit into 9 labs, that's what we did. To create the final projects, we started out with an idea, like the car simulator you will see demonstrated momentarily, and then we incorporated different pieces from as many of the applicable labs as we could.
Here we will be demonstrating the car simulator, which is one of the 5 final projects that we were designing this lab. This project. For this, the components used, the students are expected to use various components that they learned in previous labs. For example, LEDs, which will be used to simulate the brake lights and headlights. Lab 2, with the push button, which we use to control many components of the car. Lab 4, where the students learn input sensors with the potentiometer and the ultrasonic sensor. Lab 6 were outputs, where they will be using the display screen for the indicator, car indicator, and the piezo speaker for the car horn. And then Lab 7 and 8 for the DC motor simulating the car speed. So as I simulate this, you'll notice that in the off state, none of the components should work. And then when I turn the potentiometer, which is used as the car ignition, it's in battery on. And you'll notice that when I control the car, that's the car horn, light switch for the headlights, brake lights. And then you'll notice that the car speed doesn't turn on because we're in battery on mode. But once we're in engine on mode, now the car will run. I can stop it by braking. Headlights should still work, and the car horn should work. And an additional feature is that they can add other components. So for example, I added the ultrasonic sensor as a car sensor alarm. So you'll notice that when I put an object close to it, it warns the user that something's getting close to the car. And then just to show quick, when I turn it off, nothing else should work. And this is the car simulator being demonstrated.
We are planning to do some future work, and one of them is we will try to find some smarter way to spend the budget, because there are a lot of part that needs to be accommodated for each lab and project. Also, we'll try to get some people to test our project in case there was any bug that we were not able to figure out ourselves. Also, we'll design some pre-lab and some post-lab to make sure that the students come in the lab prepared, and also to make sure that when they leave the lab, they are doing some extra work and getting much more familiar with the concept learned in class.
So in the end, we designed 9 labs, keeping in mind who our audience would be, being the mechanical engineering students with the limited coding experience and familiarity with the electrical concepts. We had the labs be designed to be increasingly complex as they move forward. And in the end, we designed 5 projects for students to work on using the lab concepts that have been introduced to them, and also combining them in increasingly complex ways to show that they had fully understood the lab concepts that had been presented to them in the past. That will be all, and thank you for watching the video.